This is chapter 4. So here we have FeCl2 and FeCl3. So these are ionic compounds because here Fe is metal, Cl is a nonmetal. So again, in naming ionic compounds, we don't use prefixes. So here, this will be named as iron chloride, and the same thing for this one is also iron chloride. Now again, these are two completely different compounds. So how do we differentiate them in terms of their names? Now first, this is caused by the iron here because this iron, this metallic ion, the iron here, has a variable charge. If you look on the table, so here the charge of iron can be either positive 3 or positive 2. So its charge can vary or its charge can change depending on how it uh, combine with other elements. That's unlike other elements because as you observe here, for example, hydrogen, it has a constant charge. It's always positive 1. Then for lithium, positive 1, beryllium, positive 2, and so on. So that's unlike other elements here. So as you observe here, some elements have variable charge. And on this case, we need to tell the number of charge on the name of the compound. So first, we need to identify the charge of the Cl of the iron here. So let's start with the Cl. So Cl has a constant charge. So for Cl, it's always negative 1. So we know that for Cl, this one is always negative 1. Here we have dalawang Cl. So again, each of the Cl ion has a charge of negative 1. If we have 2, then we have negative 2 coming from the 2Cl. Now the overall charge of an ionic compound, this one by the way is 0. So neutral yung overall charge ng ionic compound. So if the charge of the Cl is negative 2, so what is the charge of the iron here to neutralize the negative 1? So this must be positive 2 to make it 0. So in this case, the charge of the iron here is positive 2. So the name for this one will be iron 2. Again, this one will be iron 2 chloride. So this 2 here, that's the charge of the iron on this compound. Next, we have FeCl3, the same thing. It must be neutral. Again, the charge of Cl is always negative 1. We have 3 here. That is negative 3. So to neutralize this one, the charge of the iron must be positive 3 to make it 0. So again, here the charge of iron here is positive 3. So this one would be iron 3. So this one is iron, then we have 3 chloride. That's the name for these compounds. Next we have Cu2SO4. So here we have copper. If you look on copper, copper also has a variable charge. Sometimes it's positive 2, sometimes it's positive 1. Let's start with the SO4 here. So for the charge of SO4, it's over here. The charge is always negative 2. So again, the charge of this ion is negative 2. So to make it neutral, what do you think is the charge of copper? And note that here the copper is dalawa. So we have dalawang copper here. So what's the charge to make it? Of course, on this case, the charge must be positive 2 from the overall of the copper. Now, what's the charge of the individual copper here since we have dalawang copper? So we can use here the positive 1 a charge because positive 1 times 2 is positive 2. So in this case, the charge of the copper here is positive 1. So this one will be copper 1, then sulfate. Again, copper 1, copper 1, copper 1 sulfate. Copper 1 sulfate. Again, here the 1 is the charge of the copper in this compound. Next, we have Sn. This one is tin. Again, here tin can have a charge of either positive 4 or positive 2. So we also need to put these numbers, this charge on the name of the compound. So first we need to identify the charge of OH here. For OH, it's over here. So let's see. OH, this one is hydroxide. It's over here. The charge is negative 1. Negative 1. So overall here we have dalawang group of OH. That's what we see here on this parentheses. We have here parentheses, then we have 2. So overall, the charge of this OH is -2. So what's the charge to make it neutral? The charge coming from this one must be +2. So that's it. So the charge on this one must be +2. So this one will be named as, we have tin, and then the charge to hydroxide rather. The OH group here, again, you just refer to the table for the names. Again, OH, that is hydroxide.